Hello everyone. This is going to be an overview of a project I've been working on for some years now. It's a development tool for the Commodore Vic-20, specifically a machine language development tool. So if you're not familiar with native development on the Vic-20, I'm going to give a little history here before I jump in. Feel free to skip ahead if you're already familiar with this stuff, but most assemblies for the Vic-20, of which there aren't that many, use the default line editor, so the same editor that you use for BASIC. So you just type your assembly into the BASIC linked list. So this is you give it a line number, put your assembly instruction here, and that would just let you basically store the text as if it were your basic code. The assembler would really just intercepts those instructions, so it would insert itself between the basic interpreter and the vector that reads a command. So if you're not familiar with the line editor, there's probably a lot more videos out there for that, but yeah, basically you would just write your code like this. If you want to put something between lines, you'd have to choose a number between the numbers you want to insert it within. So yeah, it's not the most ergonomic by today's standards, but definitely familiar if you've programmed on the Commodores before. But yeah, I did grow up with it, so I kind of found it a little disorienting at first, which is one of the inspirations behind this project. Also, another thing to note is if you look at the resolution of the Commodore Vic-20, obviously it's pretty limited. It has very wide pixels. These are 8x8 characters, but same as the Commodore 64, but much wider. Slower pixel clock by far. So both of those things were things I wanted to address: the editor and the resolution with this project, which, like I said, it's an assembler, but almost more importantly, it's an editor. The editor probably took significantly more time actually than the assembler itself. Okay, so this is the screen you get when you boot up this program. By the way, if you didn't look at the load address, it does require a lot of RAM. It pretty much takes the entire 24K of lower expanded RAM and then uses there's also an 8K block at A000, but that's also used by this for data storage. So it does require a 512K RAM expansion. The only one that's currently available, to my knowledge, is the final expansion. I have the alpha version, which is the same thing without the SD to IEC built in. Works pretty well. So yeah, not too much to see yet. You can see in the lower part of the screen, that is the current column number, the line number, followed by the total number of lines, and then in the bottom right we have the name of the buffer. But you can already tell it's a proper text editor. So you probably saw there that wasn't me shifting it. It will auto format your code. Labels are not aligned, or not indented. They're left aligned. So as long as you type a valid label, it will be aligned to the left part of the screen. Supports comments, of course. If you a vector, it's probably that one. Put a character up the screen. And if you haven't figured it out yet, oops. This is just a Hello World program. Yeah, so navigation is done similar to VI. VI was a big inspiration for the editor, so you can use HJKL to navigate. G goes to the top of the file. Capital G goes to the the last line of the file. You can open a line, Shift O to open above. You can delete a line with DD. Open a line below with lowercase o. So a lot of the VI commands, a pretty large subset, is supported. You can go to the end of a line, end of the word, beginning of a word. Yeah. So quite a large set of the VI navigation commands. You can also put a number of repetitions in front of a command, so 4 up, for example, or 5 down. So, yeah. You can even copy and paste, so pretty advanced features for an editor on an 8-bit platform. To my knowledge, nothing on the Commodore 64 even supports most of these, certainly not TASM, although it's a fairly powerful editor itself. So that's why I said this is almost the biggest part of this project, is making this editor. And of course this is a pretty small file, so these might not seem as necessary, but if you're trying to write serious code, I think it really improves the experience. So if we press F3, that will assemble the program. Just realized I forgot to initialize our X register. And you can already see how just in, for example, fixing this line, how much nicer this is than typing a line number that's between JSR, E55F, and loop. You know, it's just a lot more modern. And there is, I should note, one other full screen editor assembler for the Vic-20 called VASM, which kind of implements a subset of TASM's features, but it has a lot of restrictions for good reason. I mean, it takes a lot less RAM. It is, if I remember correctly, is 8K or less of RAM. Its runtime. But and also it was written in 2002, so it was far before, you know, things like a 512K expansion were available. And also just the state of Vic-20 development at the time was still pretty early. I think until the mid-2000s, maybe 2010 even, is when you started to see a lot more experimentation from some people in the scene on the Vic-20. But really through the 80s and 90s, it was mostly about the Commodore 64. I mean, there are exceptions, of course, but PU-239 and some of the groups out there. But yeah, so it was cool for its time, but had a lot of limitations. Labels had to start with an L and then 4 numbers, so super limited label names. So yeah, I wanted to address all those kind of things too. And okay, so like I said, F3 assembles the program. Now it's 2 3-bytes. After that, LDX00 is added. And if we want to test our program, you know, typically something like TASM, you would write your program, assemble it, and then just run it and see what happens. Or maybe use a separate monitor or something to debug it. Oops. Okay, so This actually lets you generate debug information, so, and has a full visual debugger. So Shift F3 will assemble with debug information. As you can see, we got an error, unnamed buffer. Of course, to assemble with debug information, we actually need to, our buffers need to have a name because the debug information required, it needs to have something to refer to that buffer. So try that again. Okay, yeah, the error didn't go away. I should clean that up, but it did succeed if you saw done 2-3 bytes. So now, if we press Commodore key plus D, we get a prompt that will accept a label like main or loop or done. If we don't press any, or if we don't give it a label, it will just go to the program origin or the lowest defined origin, which is 700 in this case. And here we go. So this activated the debugger, and as you can see, it has line number information, so it knows that our breakpoint was on line 3. It installs a breakpoint at the at the origin address and it begins execution. But at this point, it's up to us. We can really just do whatever we want. All the usual debug commands: step over, or step into, step over, go, or continue. So yeah, these ones are in ROM at the moment. You cannot step into ROM. That would require me to handle those a little differently. It's theoretically possible, but the way breakpoints work is you actually write a BRK break instruction to the instruction that's having a break at. But obviously in ROM you can't write to that. But anyway, like I said, that could be worked around, but the point is, for now, those are treated like step over if you're stepping into them. But yes, Commodore key plus Z will step into the next instruction, step over if it's ROM. And if you see the screen flash, that's because in cases like, if we're stepping over, like a subroutine, we don't know what exactly is going to be executed. So because the Vic-20's internal RAM is the only thing that the Vic chip can see, we have to use it for the debugger. And it's also very likely that the user program is going to want to modify that. So we can't assume that those subroutines won't modify internal RAM, everything below 2000 really. So we have to save it before we transfer control back to the user program and restore it when we get back ourselves. But if you notice, like in the next instruction, there's no flash because the debugger knows that LDX00 won't do anything shady with the RAM, you know. Also note, after that instruction, that X is highlighted in the register view at the bottom. And that is because the editor, or the debugger really does a lot of 6502 simulation for things like knowing what RAM needs to be saved and everything, but also just while we're doing that, we might as well give the user some more information. So LDX immediate will affect the X register, so it is highlighted in the register view. Even if the X register doesn't change, we would still highlight it because it's not based off like a delta of the old value and the new value. It's just based off the instruction itself. We know that LDX does that. LDA, same thing. Notice the far right of the bottom. ADDR, that's the effective address. So LDA message comma X, the address that's doing a load. So the 6502 is reading from the address 7016 for that instruction. This is another subroutine call to ROM, so the screen will flash. And there we can start to see our hello forming. When I'm pressing space here, that's what's swapping this RAM out. And that's so that you can see as you're debugging what the state of the internal RAM looks like, which, like I said, is what the Vic is looking at. So if you want to see visually what's going on as you're debugging, you just press the space key. But I think we kind of get what's going on with this program, so we don't need to keep stepping. We can go down here, and if I press Commodore key plus B, that will toggle a breakpoint at that line. So just like everything else in the debugger, breakpoints are visual. You don't need to know what address you're setting at. It's sufficient to go to the line number. And yeah, so if I want to continue until a breakpoint, I use the Commodore key plus G key combination. And there you go. You can see it ran all the way, did all those iterations. If I press space, you can see our program. So yeah, that's the basics of it. There's more features to the debugger, like if I press F3, that opens the memory view. So I can do like, I can just modify a memory value. 3 is, these are the screen codes for Hello World, so this is going to be C instead of H. So you go Cello World. If I press the back arrow, that returns to the editor. If I press F1, that will maximize the editor again. There's a couple other viewers. F5 shows the breakpoints that are active, so you see the one that we just added there. F7 shows watches, which we haven't gotten to, but maybe another time. Watches basically just let you, I can show it. So if we want to watch a value, we just open the memory editor, do the Commodore key plus W key combination. Then we press F7 to go to watches, and you can see our watch there. Sorry, there was a glitch, but the editor can get out of sync. This is one of the biggest issues I've fought as I've worked on this, is the synchronization of the source with the text on screen. But I try to keep the manipulations to a few primitive things, but there are, you see, when you're like doing more advanced stuff, still working on a few of those. But yeah, so there you can see our watch point. The current value is 5. If that value changes, the watch editor will be activated. But yeah, so that's about it for this basic Hello World debugging. So if I can just quit debugging, I go to the back arrow key and then press the Y key to confirm. Yeah, of course, this editor wouldn't be much use if you didn't have the ability to save and load. So if I press the Commodore key plus L, that will bring up a list of the directory for the mounted disk, or if it's an SD card, or the physical disk if it's a floppy drive. And maybe this will be more interesting as far as bigger files. So this one has every instruction. And you can see you can scroll throughout the file. Files can be quite long. They use a gap buffer, so it's not like extremely expensive to manipulate text typically. Again, that's a limitation of some of the other VASM, especially, is really just a linked list also. Under the hood, it's almost a line-based editor. It just presents as kind of a full-screen text editor. But yeah, so while we're in this big file, I can show another feature. So if I press the slash key, that's /, the only slash on the Commodore keyboard, but I can search for text. This takes a second, but there you go. So SEC. Yeah, and this is just where the bigger files is where all the nice navigation usability things really shine better. But this program otherwise doesn't do too much interesting. If we load the directory again, this is a macro assembler. So you can have macros. The macros can have other macros within them. So here we have a set macro that uses two other macros, LDXY and STXY, so load XY and store XY. And these can also be, you can debug them. And there you can see it's one line for all these, the expanded instructions that come out of this macro. But if you look at the register view, you can see what's going on. Forgot to put some of the test programs on here, but if we just go back to hello, maybe I can show. If you press Commodore key plus Y, you get a symbol viewer. So this shows you all the labels in a program and their address alphabetically. There's some other constructs like rep, which will repeat the lines between .rep and .endrep by the given number of iterations. This is just like a parameterized assembly for each line here, and as you can see, it does support macros as well. Hopefully you believe me, I don't care to really test all of these at the moment, but see if there's anything else worth noting. There's conditional assembly. There is, this is worth noting. There's, again, not to drag VASM too much, but it's pretty nice when you're writing assembly to be able to use expressions. They're just it's a lot easier to understand some constant +1 instead of some, instead of evaluating that on paper and just writing it into the code. It reads a lot nicer. So this has pretty advanced expression evaluation, supports order of operation, supports multiplication and division, something that not every assembler does. Not every 8-bit assembler, I should say. Yeah, so I guess this one maybe it's worth testing. So just pay attention to the register line. You can see these expressions and their respective values for the accumulator. So yeah, pretty neat. And I don't know if this has anything interesting. No. So we've actually run out of buffers, so it's just appending to the open buffer, it looks like. If you press F5, yeah. So there are 8 buffers in total. Each is stored in its own dedicated bank on the final expansion, so I forget the key to close them. Actually, I think it's, I don't know. But yeah, if you press F5, you get a list of all of them. You can select which one you want to go to with the respective number key. So if, say we want to open Mac again, just press 3. You can also navigate through them with the what do you call them? Less than or equals, or sorry, less than or greater than sign keys. So less than will go left and greater than will go right. So yeah, everything is pretty well isolated. Like the user program gets its own bank of 32K of RAM. The source files, they're up to 8 buffers, get their own banks, and the program itself gets its own 32K. Yeah, and the way it works is when you assemble to, say, something that would otherwise conflict with like the internal RAM, for example. If you're running code into address space, or anything below 2000 hex, or actually including the color RAM, so below 2000 and between, or even including the Vic register, so basically above 9000 or 9000 to 8000, A000. That RAM is kind of virtualized. When you perform reads and writes to that RAM, it's actually redirected to some, and this is from the editor assembler's perspective, redirected to some safe place for it, so that when it's executed, when like the user program is executed, we can recall it from that and put it at the proper internal RAM address. Yeah, so there is a concept of virtual memory, and that's what I was referring to earlier when you see the screen swapping out during debugging. Yeah. So I think I'm sure I'm missing some features, but I think that's a good start. There's a few bugs to fix. Probably saw one or two over the course of this video, but yeah, that's what I'm working on now. Hopefully I'll show some more interesting programming on this. I think it's really cool to see programming on the hardware itself. Yeah, and stay tuned for that, I guess. Thanks for watching. See you later.